Hey guys, so I actually needed to make a couple of changes throughout this. So you're not going to be required to put in an R square value, and that's because we're not looking at the difference between two variables. We're just going to be looking at how much force is recorded when we're pulling it across different surfaces with different types of mechanisms. So for one, we're just sliding an object across. We're seeing how much force it takes just to slide it across. And then the other one, we're using a cart that has wheels, and we're seeing how much force is required using the cart that has wheels. So as I go through this, I'm going to make some changes. So the first thing that I'm going to talk about is the fact that you need to go into your Google Drive, click on the three things, 3 by 3 squares. Click Google Drive. It should load this page right here. Click New, go to Google Sheets, and you will load a sheet that looks like this. First things first, title this at the top Friction Lab number 2 with your name. All right. So first things first, I'm going to ask you to put in column A your trial. And we're going to do trial. We did 5 trials. So we're going to do 1, 2, 3, 4, 5. Now, I want to show you a cool little trick. If you had like 100 trials, which we determined in class, it's really hard to have like a huge number of trials because of a couple of things. How much money you have, and how much time you have, and how many employees you own or employ, um, how big your company is, or how many machines you own, and who can man those machines. And so there's a lot of factors that can kind of like roll into how many trials you can look at. All right. So if you're doing over 100 different trials, there's a easy trick that I can teach you, which involves Google spreadsheets and Excel. So the first thing is start your pattern off. So we have 1 and 2, and so Google spreadsheets can actually figure out your pattern pretty quick. If you notice that my cursor is just what it looks like normal, all right? And if I move or hover over the little blue square, it changes to like a crosshair. Now, if I click on it and drag this down, it recognizes my pattern of 1, 2, and it's like, oh, you're probably going to put 3, 4, 5, right? And so then that's our pattern. So that's a really nice little trick that you can have. Across the top, in column B at the very top, I've labeled this rolling force N of sandpaper. Remember, the N stands for newtons, sliding force, newtons of sandpaper, rolling force, newtons for the carpet, and then sliding force, newtons of the carpet. I've put in my amount of data. Something I want to point out really quick to you is that if you notice that pulling over the sandpaper is significantly um, larger than, um, sorry, rolling over the sandpaper is significantly larger when looking at the sliding force compared to the carpet. But the cool thing is that when we compare the sandpaper with rolling forces, which is right here, notice how much force is reduced. Okay, so that's going to be an important topic that we're going to talk about. The force here has been reduced significantly using some sort of tool, okay, that can actually help us roll over a surface. Um, and that's the same for both the carpet and the sandpaper. So the rolling force is smaller here, and it's smaller here when we compare it to the sliding force. All right, so that's something we can take into consideration. So I'm going to go ahead and click on the trial. I'm going to scroll over to E1, and then I'm going to go all the way down to E6. Now remember those two numbers, because this is going to actually come up and we're going to have to make some changes. So E1 to E6. Okay, so we're going to go ahead and hit Insert Chart, and it gives us this crazy looking graph right now. And notice something, we still have 5 different trials here. Okay, we have 5 of our trials, and also we have all the top types of forces. But something's going to happen when we change the type of chart we're dealing with, and we're going to go all the way down to scatter plot. Some things are going to change. We still have our 5 trials, and we still have our 4 different types of forces that we're pulling over. But something's going to change really quick, and that is when I click here. When I click the or uncheck the box that says switch rows and columns, it loses one of our forces. And so we have to add it back. And the only way to do this is by clicking on add series and remembering that data range. Well, if you remember, our data range was E1, and then for writing in any kind of code, if you're going to do something like something to something else, the word to is a semicolon. So E1 to E6. And so this is going to pick all of that data that's in between these two sets of data points, and we're just going to go ahead and map those. Notice that it comes right back in. So we have rolling force of sandpaper, sliding force of sandpaper, rolling force of carpet, sliding force of carpet. Looks really nice, doesn't it? And we have them all pop up here, and they look really good. All right, so now we can do some changes. Notice that our x-axis is already done. Trial 1, 2, 3, 4, 5. We do need to put force over here, so we're going to go ahead and switch to customize chart title. I'm going to go ahead and oops, change some of the stuff I hit on accident, copy paste for some reason. But what we're looking at is we are looking at the amount of force in newtons of a cart and sliding block that are approximately 200 grams moving over 2 different surfaces. Okay, and so I'm going to go down here, make it sure it's in the center. I'm also going to bold it, and that looks really nice. So the force in newtons of a cart and sliding block, approximately 200 grams, moving over 2 different surfaces. Okay, and then we have our titles for what each of these represent. Now, I will say that we could probably change our y-axis. So if we go to vertical axis, we can put a title in here. And this is going to be force in newtons. Notice it popped up right here. That looks really nice as well. We're going to go ahead and close out of here. Then we're going to, I would like to increase our vertical axis a little bit and give us a little bit more of a maximum range. So notice it only goes up to like 1.5. We can change that and go just beyond that 1.75 if we wanted to. It would take us directly to 2 because it's incremental by 0.5. So 2 would be actually appropriate as well. And it just gives us a little bit more um, data to play around with. Okay, so we can see, because this one was just a little bit above 5 or 1.5. So we want to make sure that we can actually see it. Okay, so again, we do not need to go to series, and we do not need to play around with the r-squared values. Biggest reason for that is because we're not comparing 2 different variables. So I'm just going to make these stars, and then I'm going to put in here trend lines, and we can see that these are pretty consistent trend lines. Okay, and if we did put in an r-squared value, since we're not comparing 2 different variables, we're going to get like r-squared values of 0. would show that there's no statistical difference between the two values. And that's because we don't have two values to compare. So it's not a big deal. Okay, so this is essentially what your graph should look like when you're done. It looks a little different than the last one, but it's a really nice way of looking at the fact that when we are sliding over, for example, sandpaper or a rougher or more texturized area, that we're going to have to generate a force that's much larger in order for us to move that object. Okay, so this is really nice. I'm going to go ahead and let you turn this in. Remember, this needs to be done the next time we come to class. But if you have any questions, email me, please. Thanks.